Hey guys, welcome to part 2 of the Algebra and Functions videos. We're doing the Calc for this one. Again, this is just going to be me running through the test, talking about common mistakes, running through the solutions, and that's pretty much it. So with question 7, it takes 8 full bottles that are each 1.5 liters big to contain a volume of liquid. To contain the same volume, how many containers would be needed if each was 2.25 liters? Now, in a sense, this is actually inverse proportion. Okay, the bigger the bottles, the less bottles you'll need, or the how do I say this? The higher the number of bottles, then the smaller each one would actually need to be. So as one goes up, the other one goes down. Okay, and that's inverse proportion. What is constant for this, okay, is the volume of liquid. So that's what we want to start with. So we could plausibly put this in inverse proportion, but I think it makes a bit more sense to just talk about the volume of the liquid in total. Okay, there's 8 1.5 liter bottles, and they are all full. Okay, so this 8 times 1.5 is 12 liters. If you're not sure how to times by 1.5, it is the Calc section. You're welcome to check that on your calculator. Now, if the volume is 12 liters and we're trying to split this into 2.25 liter bottles or containers, then we're going to take this 12 liters and we're going to divide it by 2.25. How many 2.25 liter bottles do we need in order to get to 12? Now that one, I'm going to need a little bit of help. 12 divided by 2.25, we get 5.3 recurring. Okay, but in the question itself, it suggests that we round your answer appropriately. Now for something like this, we can't have 5 1/3 bottles, and if we have less than 5, or if we have 5 bottles, as in we round down, then we don't have enough containers, so we really need to round up. We're going to fill up 5 and then a little bit of the 6th one in order to contain that 12 liters of volume or capacity. Alright, that's it. Rounding up is usually a mistake that people, well, rounding down is what people tend to make the mistake because they see that it's close to 5, but they don't understand the context that you actually need more than 5 bottles, 5.3 or 5 1/3, in order to contain that full volume. They round down. Anyways, question 8. Fry and Leela have bought tickets for a concert for themselves and friends. Fry paid a total of $252 for 3 standing and 2 seated tickets. Leela has bought 1 ticket of each and paid a total of $98. Determine the value of each type of ticket using simultaneous equations. Demonstrate the use of either substitution or elimination method for full marks. Alright, well, we don't have any equations. We do have a bit of information. We've got Fry paid a total of $252, 3 standing, 2 seated. So I'm going to say X is standing, Y is seated. Okay, so I'm just defining my variables first off so that I can talk about a relationship in terms of letters rather than the words themselves. So I've got 252 is equal to 3 standing and 2 seated. Now you can use A and B or K and X. It doesn't matter which 2 letters you use, but X and Y is just kind of the standard, so that's what I tend to use. Leela paid $98 for 1 of each. So you add the cost of one standing and the cost of one seated, and you get a total of 98. One standing, one seated is equal to 98. 3 standing and 2 seated is equal to a total of 252. Now we have two equations, 1 and 2, that we can start to use either substitution or elimination. Now, in order to get our full marks, we need to demonstrate this algebraically. However, you could still get an extra mark had you solve this on your calculator, which I can demonstrate in a moment. Okay, I'll check my answer with it. I'm going to rearrange equation 2. All right, 98 is equal to x plus y. I'm going to say y is equal to 98 take x, because I've just taken x from both sides. 98 take x, and x take x is just leaves y. So the remainder of the $98 after I take the price of my standing ticket is my seated ticket. Now with this, I'm going to call this 3. Same formula, but I'm going to substitute 3 into equation 1. Okay, so I get, again, I don't leave myself room for these things. 252 is equal to 3x plus 2 lots of 98 take x. Okay, just doing that earns you another mark, which is pretty useful. Okay, then actually solving for x and y is the next part. Alright, I'm going to have to do it on another piece of paper again. We've got 252 is equal to 3x plus 2 lots of 98 take x. That's where we started, 252, etc. X is in 2 locations, so I need to break it. I'll break this bracket up. 2 times 198 is 196. Take 2x. Sign goes with it. We'll keep repeating that. And that leaves us at 252 is equal to x plus 196. 3x take 2x is 1x. That's how we got there. And then we're going to take 196 from both sides. Alright. We could probably do this, I think it's 56, but just to make sure, I've got a calculator there, I may as well use it. Alright, x is equal to 56. Now remember that this is for the standing. But the question itself says, determine the value of each type of ticket. I do not know what y is, but I do know that y is equal to, from equation 3 here, that it is equal to, I'll move up, sorry, 98 take x, and I know that x is now 56. So y is equal to, again, may as well use it just to be certain, 42. And I should probably put dollars on these things because they are, in fact, dollars. So we've got $56 for standing, $42 for seated. Okay. Now, if you decided that you want to do this, or you were uncomfortable doing the substitution or elimination method, and you're like, well, if I solve it, I still get some marks. I'm just going to clear the history here. So we can use our calculators. We need to be in a calculator section. So if you're in here, you want to open up a calculator or a scratch pad, it'll do the trick. I've already got it open, so I need to go to menu. We're doing algebra. Okay. We are solving, but we want to actually solve a system of equations. There's more than one. Okay, solve a system of equations. We'll do. So that was menu 371, in case you were unsure. Menu 371. We have two equations. We're using x and y. You can change those letters if you like. It's just to make sure the calculator sets up this for you. Okay? So you take your equations. I'm going to use the equations that were easier to get from the question, 1 and 2. I'm going to place them in here. 252 is equal to 3x plus 2y, and then use my directional pad to move down to the next part. 98 is equal to x plus y. The comma and this curly set of brackets here is telling the calculator that I'm looking for the answers to x and y. If you use menu 3.1, you'll see something similar. Anyways, that's the calculator solution if you're unsure about the substitution or elimination. And because with worded problems, some of us can get stuck with coming up with those equations, I've given a second option to get some marks still. I may as well do this, but I'll use this example to go through the elimination method. Okay, with the elimination method, I am looking to get, I have two equations, and I want to match the size of the coefficient of one of these variables. So I can either have the coefficients of x the same or the coefficients of y the same size. And I need to multiply, sometimes divide, but mostly multiply one or both of those equations to make it easy. Alright. Both of these are pretty simple to match the coefficients of both x or y. I can multiply 2 by 3 to get 3y, or I can multiply 2 by 2. 2 times 2 is 4. I'm going to go multiplying by 2. It's easier to double, so I'm going to go equation 2, and I'm going to times it by 2, which is equal to, and I need to times everything in here. 4x, 2x times by 2 is 4x plus 2y, y times 2 is 2y, is equal to negative 1 times 2 is negative 2. Alright, and then with equation 1, which I'll write underneath, I'm going to, how do I get rid of this 4x using this other equation? Well, I can take, and I like to use words because I'm taking the whole thing, and if I put a minus just out front of the 4x, people think that it only applies to that first term. I need to take away each of these terms from this equation here. And I write the x's and the y's and the equals and the constants next to one another or above one another so that it makes it easier to do. 4x take x, that's 0x. Thankfully that goes away. That is why I have eliminated it. 2y take 3y. Had I done it the other way, this may have worked out a little bit better, but that's not super important. We can rearrange later. 2y take 3y is negative y, and then this is equal to negative 2 take 1, negative 3, y has to be equal to 3. Not quite finished yet, simultaneous equations, two unknowns, so let's bring in a way to find x. I'm going to use 2. So I'm going to 2x plus 3 is equal to negative 1. Okay. When I substitute, I like to use brackets to make sure that I'm not going to confuse it with any squares or negatives or anything like that. I know what's in there, and then I can figure out what happens to it after. So 2x, add 3 is equal to negative 1. Take 3 from both sides. 2x is equal to negative 4x is equal to negative 2. Now I have my two solutions, and I'm done. Alright. Because I didn't actually do the worded problem, question 8, this optional section, or saved section, was worth less. Anyways. This is a tricky one. We've got to use quite a bit of information here about our polynomials. The remainder when, we're doing question 9, the remainder when the function of x is equal to ax to the power of 4 plus bx to the power of 2, take 1 is divided by x take 3 is 224. Remainder divided by x take 3 is 224. That's my first bit of information. And x plus 1 is a factor of f of x. Okay, so there's 2 bits of information here, and I'm trying to find a and b. 2 bits of information, 2 unknowns, definitely going to be a simultaneous root, or most likely will be anyway. So we need to know about the remainder theorem. Alright. With our remainder theorem, it says that if a polynomial is divided by a function x take a, now this take a is very important, okay? We'll go through a couple of examples just in a moment, but it's take a, not add a. It changes things a little bit. If I am dividing by that linear factor here, alright, then the remainder, what is left over, is equal to the polynomial at a. Okay, so if I had x take 3, a is equal to 3. If I had x plus 3, then x minus negative 3, a is equal to negative 3. These two are the same thing. So if you see a plus there, a is actually negative. If you see a minus there, then a is actually positive. Bit strange, a little bit hard to get used to with everything else that we've done, but that's the remainder theorem. Okay, p of whatever that number is. Alright, the factor theorem is when we are talking about factors of polynomials, you have a remainder of 0. Okay, so what's the best way to say this? So if it's a factor, it has a remainder of 0. So let's say we had a number. Start again. If p of a is equal to 0, then x take a, again, take a, not plus a. The next take a is a factor. Alright. Now we're going to use both of those bits of information to solve question 9. The remainder, when it's divided by x take 3, this is a is equal to 3. Alright, well, a, because I don't want this getting mixed up with the a here. F of 3 is equal to 224. I know the remainder when it's divided by this function is equal to 224. It goes back to the remainder theorem. Remainder is my polynomial at that point. So this means that x is 3, so a 3 to the power of 4 plus b 3 to the power of 2 take 1 is 224. Okay, let's simplify just a little bit. 3 to the power of 4 is 243, I think. 300 to the power of 4, no, my bad. 81a plus, this is why we use a calculator, because guessing's going to make mistakes. So that is equation 1. Right. The other part of information, x plus 1 is a factor. So x plus 1, we're talking about a is negative 1. f of negative 1 is equal to 0, which is also equal to a negative 1 to the power of 4 plus b negative 1 squared take 1. Alright, I am running off the edge of the page now, but negative 1 to the power of 4, it's an even number. Negative is going to cancel. A plus b take 1. This is equal to 0. There's my second equation. 2 equations, 2 unknowns. I'm going to go with my simultaneous equations. So let's do this. Again, menu. We've done this once before in the second part of question A, 8. Menu 3, 7, 1. 2 equations. If you want to change the letters, you can. A and B, separate them by a comma, as it says in the calculator. Alright, 224 is equal to 81a plus 9b take 1. And 0 is equal to a plus b take 1. A is equal to 3, b is equal to negative 2. Okay, that's my final solution. A little bit tricky, a lot of details there, but once you get both bits of information into the calculator is the best way to solve it. Okay, you can do simultaneous equations, but it would take you a lot longer than you have. Alright, question 10. Demonstrate completing the square to solve the equation x squared plus 10x is equal to 75. So we need to look at completing the square a little bit before we get into the problem. Okay, completing the square goes back to our perfect squares. Perfect squares when you have a plus b squared or a take b squared, and they expand in this way. Okay, a squared plus 2ab plus b squared, or a squared take 2ab plus b squared, depending on what the sign is in between those two terms are. So this is double a and b. With completing the square, okay, first thing you want to make sure is that that first term, the x squared term has a is equal to 1. Coefficient of x squared is 1. Or the number in front of x squared is equal to 1. Plenty of ways to say that. Okay, this makes this easier because we're going to have half of this term. In fact, I'll write it with x's instead. X take a, or add a all squared is x squared plus 2ax plus a squared. We are trying to form this and then go back here when we are trying to complete the square. Okay, x has to have a coefficient of 1, and we're going to half this middle term, the x term, to find out what a is. Half the x term to find a. Okay, but then we need to add the square of a to both sides. Then from there, we are completing the square. And this can all be done pretty swiftly in one step once we understand the pattern. Okay, so let's demonstrate. Here's my x term. I need to halve it. Half of 10 is 5. So a is 5. Okay, it should be squared. Taking this part here, x plus a squared. I've found a by halving the x term, okay, because half of 2a is a. And then I've chucked that into my brackets and squared it. Now, to have done that, I had to add 25 to the left-hand side. Okay? Because what I'm saying is x squared plus 10x plus 25 becomes that. Okay? So to make x squared plus 10x this, to make it this, I had to add that 25 to both sides. That's the a squared. 5 squared is 25. I need to keep it balanced, so whatever I've added to one side, I've added to the other. So half the x term, square it, add it to both sides. Okay? In effect, we're taking the x term, halving it, putting it into my bracket as a perfect square with x, and then adding the square to the other side. Square of that a term to the other side. So what I've got is x plus 5 all squared is equal to 100. And then I can take the square root. X plus 5 is equal to the square root of 100, which is plus or minus 10. X is equal to negative 5 plus or minus 10. So x is equal to negative 5 add 10 is positive 5, and negative 5 take 10 is negative 15. There's my two solutions. Alright, so complete the square. Half x term, and then we've put it into brackets. And then you want to add a squared to both sides. And finally, to actually solve for x, you need to isolate x. There's your steps. Half the x term, placed into brackets with a perfect square. It's still equal to something, but you need to add a squared to that other side. Isolate x. That's it. 3 steps. Alright. Question 11. For the polynomial p of x is equal to 2x cubed plus 5x squared, take x is equal to negative 6. What is the coefficient of the leading term? Leading term has the highest power. Okay? The coefficient is the number in front of whatever term or variable you're talking about. So highest power term is 2x cubed. The coefficient of x cubed is 2. That's it. X take 1 is a factor of px. Calculate the quotient. So the quotient is what's left after you've had that division. So if I did, for example, if I did 16 divided by 5, okay, then my answer, if I was doing remainders, is 3, remainder 1. This is the quotient. This is the remainder. And another word for that is the divisor. Okay, we're trying to find what's left once we've done the division. Okay, so we need to go back to our long division, and I'm doing x take 1 is, we're dividing 2x cubed add 5x squared take x take 6. Okay, you don't want to miss any terms once we're setting up this long division. So if there's no x squared term, you put 0x squared in there. Otherwise, you're going to mix your terms up and you're going to make a mistake. Alright. So, if we are doing our polynomial division, I'm dividing my first term by x. 2x cubed divided by x gives me 2x squared. What's left up here is going to be my quotient. Now that I've divided, I need to times and take the result away. 2x squared times by x is 2x cubed. 2x squared times by negative 1 is negative 2x squared. Alright, I'm taking the whole thing, not just that first term, so that's why I've chucked some square brackets around the whole thing. It's going to be easier to chuck those square brackets in than just make a mistake later down the track and backtrack. Okay, just chuck the square brackets in, it will help. 2x cubed, take 2x cubed is 0. That's what we want. If those don't cancel, we've got an issue. 5x squared, take 2x squared, take makes a positive, so positive 7x squared. Alright, bring the next term down. I'm going to use that in a moment. Next term, 7x squared, and I'm dividing by x. I'm going to have positive 7x. Alright. Times what I've just found, 7x, by this I'm taking away. 7x times by x is 7x squared. These two are going to cancel to 0. 7x times by negative 1 is negative 7x. But again, I've got negative, negative makes a positive, so I'm adding 7x. This is a negative, so on the side I'm doing negative 1, add 7. Okay, got to be quite efficient with your negative numbers, otherwise more mistakes. Alright, negative 6x take 6. 6x divided by x is positive 6. Take away 6x take 6. Alright. Remainder of 0. Because we know it is a factor, we know that there should be a remainder of 0. So if you haven't got that remainder of 0, even though you were told it is a factor, you've likely made a mistake somewhere along the way. You can use that to your advantage. Alright, and there's your quotient. Now, solve x for when p of x is equal to 0. So I've got 0 is equal to 2x cubed add 5x squared take x take 6. Remember that p of x is equal to 2x cubed plus 5x squared take x take 6. That's right at the beginning of the problem up here. Okay, but I'm told that p of x, this thing, is 0. I'm not told that x is 0, otherwise it would be inside that p, those brackets next to p. I'm told that this whole thing, this whole polynomial is equal to 0. Now, because it's only worth 1 mark, not marks, then this is just best done on your calculator. But if you don't have it, okay, we've already divided this and found that this is equal to x take 1 times by the quotient we found earlier. Okay, so you know at the very least x is equal to 1. This is a quadratic, which based on the skills that we've used, particularly in the non-calc section in the last video, we should be able to solve this. 2x squared, 6, positive 7x, 2x, x, let's go 3, 2, 3, 2, no, 3, 2 that way will give me 4x, 3x, added together, both positive, positive 7x. So 0 is equal to x take 1, opposites, 2x, add 3, and x add 2. So negative 2 is another solution, and negative 3 on 2 is a third solution. Alright, but honestly we didn't need to do all that work. We can go, and again I will try that again. I am trying to solve menu 3 algebra, solve this equation. Okay, so this is all we needed to do for 1 mark. 0 is equal to 2x cubed plus 5x squared. Anytime you're in the power, make sure you press across so that you're not constantly writing into the power. Alright, so that's my equation. I'm solving this, but I need to tell the calculator what I'm solving it for, comma, x. Alright, there they are. Negative 2, negative 3 on 2, or 1. And those are what we've found. So try to make it so that you could solve it with a non-calc. Alright, so you can solve that quadratic if you understand that once you've brought out this common factor, okay, that's what's left to make the polynomial. So this becomes that, which then I factorize again, and it becomes that. Or calc. Alright, hopefully that's helpful. And let me know if you've got any questions. See you next time.